In this lesson, we'll look at another type of factoring trinomials of the form x squared plus bx plus c. But first, let's do some review of multiplying binomials. So the first one here is x plus 3 times x plus 2. We could use the FOIL technique to go ahead and figure out the answer. First terms multiply together to be x squared. Outsides are 2x. Insides are 3x. And last is 6. Now remember, when we did this before, you combine like terms. So the final answer is x squared plus 5x plus 6. In the next one, same thing. First is x squared. Outside is 9x. Inside is negative 4x. And last is negative 36. We combine like terms to get x squared plus 5x minus 36. Our goal in this section is to be able to take these answers that we got and go back to the original. So in other words, factoring is just a reverse process. You're going back and undoing to get back to this original two binomials. Anytime this happens, there's a special way that B and C are connected. Let me show you here whenever we multiply through. We'll always have that x squared first, and then an s times x, we'll have for the insides the r times x, and finally r times s. These two terms in the middle are like terms. So we end up with x squared plus s plus r plus rs. This is important because what it tells us is that there's a connection. The middle two terms are the s and r added together. The last two terms are the r and s multiplied. So we think of this as our b value, and this is our c value. Let's go ahead and look and see what this is actually going to look like in practice. We know that this first one used to be these two binomials. In fact, we know that the first terms used to be x's. That's the only way we could have gotten an x squared in the FOIL process. For the next part, I'm going to use that whole idea we said before. The c value is the multiplied numbers. The 7 are the ones that were added. So I'm trying to think of two numbers that multiply together to give me 12, but add up to be 7. Now, some of you might be able to do this in your head because you're really good at mental math facts. If you're not, make a list off to the side. There are lots of possibilities for 12. We have 12 and 1, 4 and 3, and 6 and 2. But remember, you're choosing the sum to be 7. So we have to use 4 and 3. That means it'll be x plus 4, x plus 3. The best part about factoring is if you're not sure you're right, you can always FOIL it to see if you come back to the original answer. Okay, look at the next one. In this one, once again, I'm going to have two x's to start. The key thing is, though, this negative sign first. We didn't have any negatives in the previous example. We're trying to multiply two numbers together to get 24, but then when you add the numbers, you're going to get a negative. The only way that's going to happen is if both of the factors are negative. Okay, let's jot some down. 24 has a lot. 24 and 1, 12 and 2, 8 and 3, 6 and 4, think that's all of them. I'm trying to choose the two of them that would make 11. But remember, we're thinking all of these have to be negative. So I'm going to choose the 8 and the 3. Minus 8, minus 3. Let's do a few more. In this one, I'm trying to think of two numbers that multiply together to give negative 10, but add up to be 3. Now, the only way this is going to happen is if one of them is positive and the other is negative. So I'm going to have a positive and a negative. This is going to give you a lot more options, unfortunately, because if I use something like negative 10 and 1, I also have to consider 10 and negative 1. Or negative 2 and 5, I'll have to consider 2 and negative 5. We're trying to select the ones that gives me a positive 3. Right there it is. Minus 2 plus 5. Okay, for the next one, think of two numbers that multiply together to give you negative 8, but add up to be negative 2. Has to be one positive and one negative to make this work. Now list all the factors of negative 8, like negative 8 and 1, 8 and negative 1, negative 2 and 4, 2 and negative 4. I want to select the one that adds up to be negative 2, that middle number over here. That would be this one. So I want positive 2 and minus 4. Couple more, just keep going with some practice. So this one starts with a negative. So that's a key thing here. That negative tells me that when I multiply together, I'm going to get a positive 12, but I have to add up to be a negative 13. And we talked about this earlier. Whenever you have that situation, that means both of the numbers are going to have to be negative. So I want to think of things like negative 12 and negative 1, negative 3 and negative 4, negative 6 and negative 2. Both of them have to add up to be negative 13. Of course, right here it is. 12 and 1. This next one I think is kind of difficult, just for the mental math facts and the arithmetic. It's kind of strange. You have to multiply two numbers together to get negative 56, which is a fairly large number. But when you add them, you get negative 1. I do know that because it's negative, I'm going to have one positive and one negative. So let's think about all the different factors of 56, like 56 and 1. Actually, one of those has to be negative, so negative 56 and 1. 56 is even, so I know it's divisible by 2. That would be 28. Negative 2 and 28. But this just doesn't seem to be working. Remember, we have to add them together to get negative 1. I need numbers that are really close to each other. So I was thinking about 8 and 7. Right here it is. Negative 8 and positive 7. With factors that are large numbers, it is best to jot down on the side of your paper some different options you have. At least you have some choices then, instead of just trying to think of random numbers. Okay, for our last one. This is all positive, so that makes it nice. I'm going to think of two numbers that multiply together to give 12, but add up to be 10. Like 12 and 1, 3 and 4, 6 and 2. I just can't seem to find a 10, though. I mean, this is 13. This is 7. This is 8. There are none. This is actually impossible to factor. We know in mathematics when you can't find factors, we call it prime. This is actually not factorable, and it's a prime trinomial. In other words, no factors. I have a trick question. Just doesn't even work. There's nothing that will satisfy those requirements. Okay, let's go on to solving equations. So in the last section, we looked at difference of squares, that factoring, and then we solved with it. Now we're going to use this trinomial factoring to solve. So the trinomial is set equal to 0. We'll start it the same way. I'm going to go ahead and factor. We have two numbers that multiply together to give you 15, but add up to be 8. That would be 3 and 5. The zero product property tells us that one of those has to be 0. Either the x plus 5 or the x plus 3. By solving each one of these equations, we find that one answer is -5, the other is -3. So two different solutions that works. Another one, in this factor, I need to multiply together to get -6, which means one will be positive, one will be negative, but they're going to add up to be 5. This is a little bit more difficult for me to think of, so I'm going to put some work off to the side, like -6 and 1, 6 and -1, -2 and 3, and 2 and -3. I want it to add up to be 5. So I'll choose this one. +6, -1. One of these factors has to be equal to 0. So I'm going to go ahead and solve for both. One of the answers will be -6. The other answer will be +1. That's important to note when you're doing the factors. We found 6 and -1 to be the actual factors that go in this equation. But you'll notice how the opposite answers are going to be the solution. And that's because we have to solve these individual equations. Here's one that's really different. We don't have that 0. So I'm going to go ahead and subtract 45 from both sides to get a 0. Now it looks more like what we started with in the other examples. This is the letter Y, but it doesn't make any difference. If you don't like the different letters, just change them to X's. I want two numbers that multiply together to give me -45, but add up to be -4. It's a negative number, so I'm going to make one positive and one negative. 45 could be -45 and 1, 45 and -1, 15 and 3, 9 and 4, or 9 and 5. I want to choose the one that adds up to be -4. Right here it is. -9, +5. According to the zero product property, either y plus 5 equals 0 or y minus 9 equals 0. So I have two solutions, -5 and +9. Last thing we need to do is look at some problem solving. So I just found one problem that I think will be a good example. Finding two consecutive integers whose product is 72. Now I guess you could sit around and just think about it and use trial and error, but we want to use actual algebra and set up an equation to solve. If we have two consecutive integers, I'll need some variables. Let's let x equal the first integer. If they're consecutive, that means one right after another, like the numbers 1, 2, and 3. They're consecutive. So if the next consecutive integer would just be one more. The key thing in this one is the fact that it says product. The word product means multiplication. So I'm supposed to multiply these two numbers together and make them equal 72. So x times x plus 1 equals 72. We have to do a lot of work to set this up. One of the things that students do incorrectly is assume you can set x and x plus 1 equal to 72. That only works for the zero product property. So we're going to have to do a lot of rearranging and some distributing to get things on the correct side. The first thing I'm going to do is multiply through by x. And then I'm going to subtract 72 from both sides. Now I have that 0 on the right. This will factor. We need to think of two separate numbers that multiply together to give you negative 72, but add up to be 1. Lots of different factors. I'm going to go with 8 and 9, a positive 9, and a negative 8. Either x plus 9 equals 0, or x minus 8 equals 0. There's two solutions, negative 9 or positive 8. Now because it's a word problem, we can't just stop there. We actually have to find what it's looking for. It wanted two consecutive integers. So I'm going to go ahead and use my equations that I had here. If negative 9 is the first integer, the next consecutive, we just add 1 to it. There's one possibility, negative 9 and negative 8. There are two consecutive integers whose product is 72. The other possibility is for the x value to be positive 8. The next consecutive integer there would be 9. They also meet the conditions that they're two consecutive integers and their product is 72.